To complete the CER for your spherical, you need to know that Newton's second law of motion is the main focus of this investigation. The investigation is a spheral. We need to know that a spheral will use force to push a cup along the floor. The problem of this investigation is that we need to answer in our claim and support in our evidence and prove in our reasoning is how does changing the mass of the cup affect the acceleration of the spheral? So in other words, how does adding pennies to our spherical that make it heavier change the acceleration? Will it increase it or decrease it? That's what this question is asking. For our claim, we first look at the rubric, and we are focusing on getting a 3. Anything above a 3 is you going above and beyond, which is perfect. You can do that. It's your choice, but we're looking at getting a 3. The claim is clearly written and correctly defends the investigation. The claim correctly provides the IV, which is the independent variable, and dv, the dependent variable. The claim is clearly written in a way that tells the reader how the experiment was done. So you still need to include how you did this experiment. So to break this down, you have a claim that is clearly written and correctly defends the investigation. What does that mean? It means that you answered the question. The problem of the investigation was how does changing the mass of the cup affect the acceleration of the spheral? The claim correctly provides the IV and dV. You have to include the IV, which in this investigation is mass, and the dV, which in this investigation is acceleration, the x and the y. The claim is clearly written in a way that tells the reader how the experiment was done. This part, you tell what you did in the experiment. Now, we're focusing on the blue here. So when you're typing up your CER, this is a good way to, these are some good things that you should include in your claim. So changing the mass of the cup affects the acceleration of the spheral by, now how does that, when you add more pennies, what does that do to the acceleration? That's what you need to include. In the investigation, the independent variable is mass because that is the variable that was changed by the team. You added more pennies. The dependent variable is acceleration because that is the variable that was changed by the amount of pennies you added, right? It slowed down or it slowed down. We didn't have, and then this is how you did the experiment. And this is taken directly from pre-experiment 3.6 and how you did the coding. So it says we didn't have a way to accurately measure the acceleration of the spheral, but we can calculate the acceleration from a single measurement. The acceleration of an object is calculated by using the equation F equal ma. And then you can also add that we coded this using Sphero edu, and that this is how we came up with our data table. Now the evidence, again, we're paying attention to getting a 3. The graph is described with relation to the IV and dV, correctly describes the relationship, the slope between IV and dV. Data points are provided and compared to support the IV and dV relationship. So here, what do these things mean? The graph is described with relation to your IV and dV. That means you are including your I-squared statement. So if you did 3.6 post-experiment and you submitted that, you should have submitted that with your I-squared statement. And that's where you include that in your CER. In the evidence portion, you need to include your I-squared statement. And also, you need to include data points. So I'm recommending that you include the smallest mass and the acceleration and the largest mass and the acceleration to show a comparison of how the adding more mass changed the acceleration. So here's what you should be writing. From my graph, I see, what did you see, right? This is where you're adding your I-squared statement and what it means. Also, you should say, from my data table, when I applied however many grams, this is the smallest amount, the acceleration was, you have to include this. However, when I applied, this is the largest amount of pennies, and the grams, the acceleration was, and you have to include that. Also, this last sentence, this difference in mass and decrease in acceleration show as mass increases, acceleration decreases, right? In reasoning, again, we're looking at level, or to get a 3. You clearly explain why the evidence supports the claim, clearly explain the scientific concepts learned, and provides evidence of understanding by describing the sources of the information. All right, so to get those 3 points, what do you need to do? To clearly explain the evidence, explain why the evidence supports the claim. How does your data that you gathered show as mass increases, acceleration decreases? How does that work? And again, you can include certain things that you've already said, but we'll talk about that in the last part of the paragraph. Clearly explains the scientific concepts learned. What scientific concepts have you learned from the debrief that show as mass increases, acceleration decreases? So you're looking at those 3.6 debrief notes that you have taken that talk all about force equals mass times acceleration. You need to talk about that. That's Newton's second law of motion. And the last part, you have to tell where you got the definitions of the scientific concepts you learned for this unit. And so here's a good way to start this and to include the information that you have already gathered. So the evidence of as mass increases, acceleration decreases is represented in my graph, which shows, and you have to include your I-squared statement again. And this is the last part. Where did you get this information? Like, how do you know that as mass increases, acceleration decreases? And that's where you can add, well, from my 3.6 debrief notes, I have learned that Newton's second law of motion states, and you have to state what is Newton's second law of motion. Include that. Then you say, this is shown in my investigation because of the inverse, or you can say indirect relationship that mass and acceleration have in my graph and in my data. An inverse or indirect mean as one variable is increasing, the other one is decreasing. And that's exactly what you see in your graph. That's why you have a negative slope, and it doesn't look like the slopes that we've had in our past investigations. So pay attention to the blue. You may have to watch this again and include what is in blue for each paragraph. So the claim paragraph, the reasoning paragraph, and the evidence paragraph. Include what is in blue and add your own information, and you should be able to get a 3 on this CER. And remember, it is summative, so you can listen to this video again, and I wish you good luck.